Good morning, everyone. My name is Ritvik Maliya, and these are my partners Ritik Kumar, Rohan, Rittik Kamboj, Rishi Tomer, and Rohan Chopra. And today we are going to represent our topic, which is simple hydraulic machines. Okay, simple hydraulic circuit. A simple hydraulic circuit is an interconnected set of discrete components through which the fluid flows. It contains many components like hydraulic fluid, reservoir, actuator, valves, filters, etc. Components of simple hydraulic circuit. The first component is reservoir. Its main function is to store the fluid and cool the fluid in the system. Then the second component is hydraulic pump. Its main function is to provide pressurized oil to the system, and pump help in converting the mechanical energy into the hydraulic energy. Then the next component is valve. Valves help in controlling the direction, pressure, and flow rate of the fluid. There are different types of valves, like direction control valves, which helps in controlling the direction of the fluid. Pressure relief valve. These valves are connected at the outlet of the pump. They are very important component of the simple hydraulic system, as they help in maintaining the pump pressure and the system pressure. If the pump pressure exceeds the system pressure, then pressure relief valve helps in reducing the excess pressure by returning the fluid in the tank. And the next type of valve is flow control valve, which helps in controlling the flow of the fluid. And the last is safety valve, which helps in reducing the negative pressure in the actuator, which develops due to the external force by returning the fluid to the tank. Now, what is actuator? Actuator is also a component of the simple hydraulic system. So this component helps in converting the hydraulic energy into the mechanical energy. It can be linear or rotary. Linear actuator is like cylinder, which develops the force, and rotary actuator is like a motor, which develops the motion. The next component is pressure gauge, which helps in measuring the pressure of the system. Then our last component is filter, which helps in cleaning the hydraulic fluid in the system. It removes the dust and metal particles from the fluid, which protects the other components of the system from the damage. Now, working of simple hydraulic system. Firstly, hydraulic fluid is cleaned with the help of strainer present in the tank before going into the pump. Now, pump helps in flowing the fluid in the system with high pressure with the help of electric motor. It converts the mechanical energy into the hydraulic energy. Then, our fluid reaches to the control valve, which is at the outlet of the pump. This control valve decides the extension or retraction of the cylinder. There are two ports present in the control valve, port A and port B. During extension, the fluid passes through port A. During retraction, the fluid passes through port B. Then it reaches to the actuator, which produces the work by converting our hydraulic energy into the mechanical work. Now Ritik Sinha will continue from here. Ritik.
The topic is hydraulic control valve. A hydraulic control valve properly directs the flow of liquid medium through our hydraulic system. The direction of the fluid flow is mainly determined by the position of a spool, and a hydraulic system can only function as per requirements. For example, by using valves, the required size can be determined by the maximum flow of hydraulic system through the valve and the maximum system pressure. Now, hydraulic valves are mainly subdivided into three main categories: uh, direction control valves, pressure control valves, and flow control valves. All valves operate at different functions in the hydraulic system. Different valves function in different ways. For example, check valves permit the free flow in one direction and block flow in the opposite direction. The directional control valve is used to pass on the pressure medium in an orderly fashion to a particular fashion. Pressure control valve switch to a certain pressure, and then switching pressure may be adjusted on the valve. Now, flow control valves regulate the flow that is done by adjusting the size of the orifices. The next is hydraulic flow control valves, which is also a type of hydraulic control valve. Now, flow control valve is used for adjusting or manipulating the flow rate of a liquid or gas in the pipeline. The valve contains a flow passage or a port whose flow area can be varied. Now, the role of a flow control valve in hydraulic circuit is very important as its very location is critical and optimum system performance. The basic function of a flow control valve is to reduce the rate of flow in its leg of a hydraulic circuit. One of the most important applications of flow control valve in hydraulic system is in controlling the flow rate to the cylinder and motors to regulate their speeds. Now, any reduction in flow will in return result in speed reduction at the actuator. Now, there are many different designs of valve used for controlling the flow. Many of these designs have been developed to meet the very specific needs. Now, directional control valve. Directional control valve can be used to start, stop, and to change the fluid flow in a hydraulic system. The major function of a directional control valve is to control the direction of flow in a hydraulic system. They are capable to determine the path through which the fluid should flow in a circuit. Now, we can use the directional control valve to direct the inlet flow to a specific outlet port. Now, directional control valves are classified according to certain factors like inlet control element structure, number of ports, number of positions, method of actuation, center position flow pattern. Now, in a directional control flow valve, the internal control element would be a sliding spool, rotatory spool, or ball. The construction and design of the directional control make it suitable for different applications. And the next topic is pressure control valve. The pressure relief valves limit the system pressure to protect system components. There are four types of pressure control valves. First, pressure relief valve. They are designed to protect hydraulic system when pressure in the system increases beyond the specific design pressure or maximum working pressure. They are normally closed and it opens when the pressure exceeds a specified maximum value and diverts the pump flow back to reservoir or tank internally. They are located near the hydraulic pump. Now, the next is pressure reducing valve. It is designed to limit and maintain outlet pressure. They are normally open and close when the pressure exceeds the specified design pressure at the outlet. They are present near the hydraulic actuator. The third type of is sequence valve. Sequence valves are used to ensure that a certain pressure level is reached in one branch of the circuit before the second branch become active. And the last is counterbalance valves. Counterbalance valves are used in hydraulic system operating with a runaway or suspended loads. They are designed to create back pressure in the actuator return line to prevent loss of control over the load.
Now Rittik Kamboj will tell you about pneumatic power. Rittik.
As we know, pneumatics may be defined as a branch of engineering science which deals with the study of the behavior and application of the compressed air to power machines and control and regulate machines, mostly used in automotive industries and hand tools. May well also be in large scale tools. It deals with generation, transmission, and controls of power using pressurized air. Gas in a pneumatic system behaves like a spring. It is compressible. Any gas can be used in pneumatic pressures, but air is the most usual for obvious reasons. Sometimes it may be nitrous because it's safe. Exceptions are most likely to occur on aircraft and space vehicles where inert gases such as nitrogen is preferred, or the gas is one main which is generated on board. Actuation of the controls can be manual, pneumatic, or electro actuations. So now let's discuss about difference between hydraulics and pneumatic systems. In hydraulics, liquids are not compressible. In pneumatics, as we know, air is compressible. Hydraulic systems use liquids such as oil and water to perform processes. Pneumatic systems use compressed gas such as air or nitrogen to perform processes. Hydraulic systems are closed systems, recirculating the oil water after use. Pneumatic systems are open systems, exhausting the compressed air to the atmosphere after use. It's the hydraulic system is less cheaper and pneumatic systems are cheaper, but expensive than hydraulic systems. Hydraulic systems are more efficient due to incompressible fluids. Pneumatic systems are fast but less efficient. Applications. Pneumatic systems are used in many applications. In construction, it is indispensable source of power for such tools as air drills, hammers, wrenches, and even air cushion support structures. Not to mention many vehicles use air suspension, braking, pneumatic tires. In manufacturing, air is used to power high clamping, drilling, pneumatic grinding, and assembly using pneumatic wrenches or riveting machines. Plant air is also used to power hoist and cushion support to transmission loads through the plant. Many recent advances in air cushion support is used in the military and commercial marine transport industry, manufacturing industries, automotive industries, machine tool manufacture, and domestic and commercial appliance manufacturers. Processing industries such as chemical, petrochemical, food processing, textiles, papers, etc. uses pneumatic machines used in the brake system of automobiles, railway coaches, wagons, printing presses. Application of pneumatic system is widely industrial in industrial robots.
Now Rohan will tell you about advantages and disadvantages of pneumatic systems.
Advantages of pneumatic system. First is infinite availability of the source, because we in this system we use air as a source. Temperature is flexible and safe to work with it, and this is clean and no wastage, less wastage we say. And the transfer of power and the speed is very easy to set up. And the next one is can be stored easily and easy to utilize the power produced by the system. Next we have this disadvantages of pneumatic system. First is require installation of air producing equipment, and is it easy to low easy to leak, because we use air as a source. And the and second one is potential noise and easy condenses expected. After knowing the advantages and disadvantages of the use of compressed air, we can make the anticipation that these losses can be avoided. Now Rishi Tomer will continue from here.
Main components of a pneumatic system: compressor. This is the part of the system that converts normal air into compressed air. Air reservoir, as the name suggests, this stores the pressurized air created by the compressor. Valves. These control the airflow to ensure that the air is released at the right pressure level for the equipment being powered. Actuator. This is the part of the pneumatic system that turns the potential energy stored in the reservoir back into the kinetic energy and does the work. Circuit. Whilst a pneumatic system could be made up of a single valve, actuator, compressor, and reservoir, these are what the main components of a pneumatic system in its basic form would be comprised of, but more often than not, this is a whole circuit containing multiples of each, sometimes all driven off a large central compressor. Types of pneumatic compressors. These can be divided into three types: reciprocating piston compressors, rotary piston compressors, flow compressors. Reciprocating piston compressors are divided into two types: piston compressors, diaphragm compressors. Rotary piston compressors are divided into three types: sliding vane rotary compressors, two axial screw compressors, roots blowers. Flow compressors are divided into two types then: radial flow compressors, axial flow compressors. Compressor has a particular selection criteria which is as follows. Delivery volume, which means the amount of air that a compressor delivers is the delivery volume. Before selecting a compressor, we need to know the amount of volume that the system requires. Also, pressure. Pressure that a compressor provides in its output is known as the working pressure. The pressure that is required by the operation is the operating pressure.
Now Rohan Chopra will tell you about air conditioners.
My topic is air conditioner parts and functions. Blower. Air flowing from supply registers is the work of the blower. This component, which also works with your furnace, circulates cooled air into your home and pulls room temperature air back for recooling. Evaporator coil. This indoor component, located near the blower, is responsible for extracting heat and humidity from the air. This is possible thanks to the refrigerant running through the coil. Compressor. Once it has absorbed heat, the refrigerant is in a gaseous state. It passes through the compressor where the gas is pressurized and heated even more. This important step prepares the refrigerant to give up its heat. Condensing coil. This is the outdoor equivalent to the evaporator coil. As the refrigerant travels from the compressor to the condenser, it expels the heat collected from indoors to the outside. Once the refrigerant is cooled to a liquid, it circulates back inside to collect more heat in the evaporator coil. Fan. The outdoor condensing unit becomes very hot with all that overheated refrigerant running through it. A fan and fins that act as heat sinks draw the heat away so the unit doesn't overheat. Air filter. While an air conditioner can function without the air filter, dust and dirt in the air would quickly collect on AC components and possibly damage them without the filter in place. Install an efficient enough filter and you can even improve indoor air quality while the air conditioner operates. Thermostat. This is the control center of the entire air conditioning process, reading the indoor temperature and telling the air conditioner when to turn on and off. You change temperature settings here based on your needs. The higher you set the thermostat, the lower your cooling bills will be.
So from here we are ending our presentation. Thank you.